Alright, so this question is, if a mass m is attached to a given spring, its period of oscillation is t. If two such springs are attached end to end and the same mass m is attached, A is the period greater than, less than, or the same as with a single spring, and B, verify your answer to part A by calculating the new period t prime in terms of the old period t. So this question is asking about the period of a spring and then how that changes when we have springs in series. So initially we have some spring with a mass m attached. And that period is, well, period in general is 1 over the frequency. When we're talking about springs and oscillations, we usually write this in terms of our angular frequency, which turns this into 2 pi over omega. And omega for a spring is the square root of k over m. So we're going to have 2 pi times the square root of m over k. Okay? So the real question now is how k changes when we add another spring in series. So instead of just having this one spring, we now have that spring attached to another spring with the same mass m attached. When we when we have springs in series, our spring constant does change. So our period of oscillation is not going to be the same. And the way that spring constant changes is by our new spring constant, k prime, equals 1 over k of the first spring plus 1 over k of the second spring inversed. So we're going to add those two fractions and then flip it to get our new k, okay, our new k prime. So this number is always going to be smaller than our initial k value. So we're going to have a greater period. Okay, so t will be greater. And that's our answer to part A. Okay? So part B asks us to show that this is true. So for part B, we can say that our k prime will be, since these are both the same spring, they're both going to have a spring constant of k. So we can say 1 over k plus 1 over k inverse. That's going to give us 2 over k inverse. So our k prime is going to equal our initial k over 2. Now if we plug that into our period, right? So we're going to take this and we can say t prime equals 2 pi times the square root of m over k prime, right? So the only thing that changed between these two setups was our k value. We plug in our new k in terms of our old k. We have m over k prime gives us 2m over k. But we know that 2 pi m over k is our t. We want this in terms of t. So by pulling out this square root of 2, we can say we have the square root of 2 times 2 pi square root m over k, or the square root of 2 times t equals our t prime. The square root of 2 is greater than 1, so our new period is greater than our old period.